Brother Jahan.
Brother Terry. Hello
How
again.
are we?
Oh, very good, very good.
That's good.
Chuffing along. Every day is another adventure in the world of lockdowns.
Very true, very true. Recently given a bit more freedom though here in Victoria, in regional Victoria at least.
Happy days. Happy days. A little bit more freedom in Melbourne as well, I think.
Yeah,
I think
that's
they can
true.
do some outdoor dining.
Small steps, small steps.
There's a pretty hilarious meme I saw of someone doing outdoor dining, and in just the pouring rain, he had like a full dining setup, and it was just pouring rain. And
Oh,
that's
yeah. That's right. I saw
He's
that.
trying to eat this soup, and that's pretty funny.
Oh man. Well, our future podcasts should be a lot more of them will be in person, right? From now on.
Absolutely. We should do an outdoor one as well, assuming the sound quality is good. But I think I've seen some people doing podcasts that are outdoors that are nice.
Okay, yeah, I'm keen for that.
In the sunshine. We are going into summer in the southern hemisphere, so
pick up some vitamin D. Nice feeling
hugely
being
important.
outside. Yeah.
Yeah. So you're in the middle of night shifts.
Yes.
Going to start again on Thursday.
Yep. I'm in a little bit of a reprieve right now, enjoying some daytime hours, but yeah, heading back into night shift. And then you're coming out of your PhD cave, is that right?
I am. So I'll be joining you on a couple of night shifts, or maybe just one night shift this Saturday night, I think. I've picked up a shift. So I think we'll have to get together and do podcast on the job.
An interrupted, all over the place podcast, but it'll be fun nonetheless.
Oh, absolutely. Absolutely. Man, today I think we decided to tackle what turns out to be a pretty hectic topic.
Crazy.
Which is
absolutely crazy. I knew it was going to be big, don't get me wrong, but the intricate level of detail involved in discussing NAD and how to boost it or why it drops off with age is crazy. Absolutely crazy.
It is it's next level. Yeah. I think it's pretty similar to our discussion on alpha ketoglutarate in terms of trying to get a grips with something that sits in this fundamental, I don't know, nexus point in the cell where it's just affecting everything.
Yeah. And there's because NAD is so like it's used so much in so many different areas, the literature surrounding it, it's just this cloud that sort of keeps growing, and there's all these cool little discoveries in various areas that just throw you off track and down a rabbit hole, and you think, okay, well, how does that impact on its other function over here and over here? It's fun because you really do feel like you're on the cutting edge, which is true, right? Like I'm reading papers that are only weeks old, but at the same time, you kind of wish it was 2 years in the future and you had an answer to some of these questions.
I suspect 2 years in the future, we won't have an answer to a lot of these questions.
Yeah, that's very true. Very true.
We're trying to build these models of what these systems look like, but the interconnectedness and the complexity of these systems, it's something to contend with. I sometimes wonder if the better answer to longevity is like the Elon Musk approach of trying to just download your brain onto a computer. Maybe that'd be an easier problem.
Yeah, that idea used to be complete science fiction, right? But now it's looking more and more like it's heading towards the possibility of being a real world application.
Yeah.
It's a strange thing to think about. I was chatting with my dad the other day, and he was my dad put a V8 engine into a Nissan Pathfinder, which is an awesome car. The car he's got now is such a cool sleeper, and he's poring over these schematic diagrams of the electronic systems and how to get them to talk to each other, and he was discussing the binary concept that he's working with. And my dad has no formal education, by the way, like super switched on guy to self-educate to this level. Right. And once he was sort of excited about binary, I was like, well, DNA is like a quaternary level of the same digital information. And then, an hour later, we're still discussing how DNA is analogous to what he's working on. I love that sort of stuff. Finding an in with someone to teach someone an idea. I go crazy.
Really cool. Oh man.
Well, let's describe what NAD. Why are we interested in NAD? What's the?
Oh man. So NAD is, from my understanding, correct me if I'm wrong, but pretty critical in powering the cell, as well as in a lot of the enzymatic and metabolic reactions in the cell. So we've mentioned previously things like the electron transport chain, things like glycolysis. These are fundamental for producing the energy currency of the cell, ATP. And NAD is fundamental in these pathways for providing electrons and various other things throughout this process. So, broadly speaking, you have things like glycolysis, which breaks down glucose to provide energy for the cell. That consumes NAD to make NADH. And then the electron transport chain consumes NADH to make NAD plus. And so that sort of process on a really simple level gives you this ratio of NAD plus to NADH. And it's this ratio that people talk about a lot, being the so-called redox state of the cell. That's sort of my broad brush.
I like broad brushes. That's I completely agree with everything you said there. It's an absolutely vital part of energy production and maintenance. And then with the advent of sirtuins, these fantastic enzymes that seem to be the sort of main focal point for getting our cells to hunker down and focus on survival, they use NAD as fuel. So this is a small snapshot into the idea that this NAD molecule does so much in the cell. So it's not only doing all the energy stuff, but it's also powering our sirtuins, these important genes.
Yeah, NAD plus as a coenzyme is something that you see a lot, not just for sirtuins, but like I don't know, just a million different metabolic areas. And often it seems that a lot of these coenzymatic reactions that NAD plus is being used in or consumed in is to do with DNA repair, DNA regulation, just a lot of stuff to do with protecting the DNA.
Because they're the main fuel source for the PARPs, right? The PARPs.
Correct.
The things that sort of go out and fix DNA damage directly.
What's really interesting is the advent of PARP inhibitors, like a drug designed to stop your cell repairing its DNA. And you think, why would you do that? But in cancer, it's actually useful because you're trying to damage cancer's DNA with a lot of chemotherapies to kill the cancer cell. And because they're rapidly dividing, as opposed to other normal tissue that isn't, then they're more susceptible to PARP inhibitors and DNA damage.
So finding specific PARP inhibitors is like a gold mine, right? The holy grail when it comes to cancer. But just like our topic of aging, it's just one small aspect in the fight against cancer that is got its own, downstream consequences and huge barriers to identifying. It's, it's the double-edged sword of being on the cutting edge of research, right? Like 100 years ago, you would have killed to even know what NAD was doing and how it's involved in these processes. But at the same time, you produce way more questions than answers a lot of the time in scientific research, and the rabbit holes abound.
There are so many themes that I think we address every time we tackle one of these topics. One of them is the cell does not waste anything. It uses the same thing for a million different things whenever it can. So it's incredibly efficient at utilizing one molecule for 10 different jobs, or 20 different jobs.
50, 100.
And so that's true in NAD+. The other thing is antagonistic pleiotropy, so providing benefits from particular pathways. But then if those pathways linger too long or something happens, then they become a negative. And that's very true with a lot of these pathways as well, I think.
Yep. Which, that gives me a good into this concept of like how a cell works. We always talk about, this enzyme will interact with this molecule and produce this byproduct or something that's then used in other parts of the cell. And you always see these lovely, beautiful diagrams of, this thing with a nice arrow going to the next part of the step.
Yeah.
But it's a really hard thing to visualize. But if you think about what a cell's doing in reality, right? Like there's these proteins that are just floating around, and it's by chance that they hit each other and interact. And so you're relying, like, because it's so small, it happens so often, and you're relying on these random sort of interactions within the cell to occur in such a high frequency. So it makes sense that antagonistic pleiotropy, that a lot of the time you want these things to smack into each other and you're getting this good positive result. But after they do that for decades and decades and decades, the cell hasn't really thought about what's going to happen when all these things can interact with each other over such a long time that then it starts to produce negative consequences. It's just so hard to visualize because we never sort of see it that way. It's never taught that way. There was a great BBC documentary that I showed my students when I was a high school teacher, that sort of had different parts of the cell clunking along and interacting in a close to real time sort of way, obviously very slow so that you could follow it, but it blew the kids' mind to even think about it that way. And it was a super high quality BBC production that cost them a lot of money. I don't think you can get it for free. I had to get it through the school's sort of subscription status. It's very expensive, but such a good visualization model.
Yeah. No, it's super interesting. I think, the cell operates on the level of probabilities rather than on the level of on or off or on. So, 80%, 80%, 10 versus 10%, rather than like a binary off or on. But what's crazy is that this probability, or these like ranges, these tweaks, really come from stochastic binary reactions. So you have like a million stochastic binary things that smooth out into like an 80% on, 10% on, onto these level approaches. So pretty interesting. Pretty interesting. Hard to visualize, hard to conceptualize. But yeah, I guess you have to try.
Yeah. Well, that's it. We're stuck finding reality the way it is, right? So you have to deal with it in these terms. And everything's pointing to the fact that NAD is really important, right? Especially with aging. And you and I both went down rabbit holes in trying to discover why NAD decreases with age, right?
Yeah.
So, which matches our heuristics, right? We're cruising along, we age, and we tend to drop off with all these different aging characteristics and phenotypes that we've mentioned before. And that seems to correlate quite well with NAD levels. Given that NAD is so central in all these processes that have been discovered, a really good scientific logical conclusion is that NAD dropping off causes aging. And obviously that's not 100% true. It's a combination of cellular senescence and telomere shortening and all these various things that some of which we've already discussed, but nonetheless, it seems to be a great area to put our attention to. I think you went on a really deep rabbit hole that I sort of peripherally noticed and chose to focus elsewhere.
No, I think it's good. We can bring our respective rabbit holes together to form one mega rabbit hole, a rabbit warren, even. But I think you went into like a rabbit hole looking at sort of NAD pathways in terms of absorption, recycling, that kind of stuff.
Yeah, yeah. I was satisfied enough with my. So I'll get into it. So the NAD dropping off can be attributed to its consumption in a lot of ways, and we've already mentioned that sirtuins use NAD, and that the PARPs use NAD, but also this something called CD38 uses NAD and sort of breaks NAD down into nicotinamide, I think, NAM. And CD38 is produced on immune cells, and when it's produced on immune cells, it's normally in response to cytokines and interleukins, all these sort of pro-inflammatory molecules, which is a basic way of saying inflammation increases CD38, which then breaks down NAD. And inflammation tends to correlate with aging, as we've discussed before, with cellular senescence producing the SARPs, the senolytic associated phenotype. So we've got all these pro-inflammatory steps building up, which would lead us to think that we've got CD38 levels increasing, which is sort of burning through some of our levels of NAD. So, which, chicken and egg, are we inflammaging because we're decreasing our levels of NAD, but we're only decreasing our NAD levels because we're inflammaging? Again, it's just a small aspect into this huge question of why we age. But
yeah,
I think I sort of stopped there and then started to focus in on how we absorb various supplements and trying to raise NAD levels. But before we get into that, you focused on a separate area of NAD levels dropping off with age, didn't you?
I did, yeah. I was looking at trying to connect some of the dots between NAD falling with age, these pathways that you mentioned, then things like CD38, things like PARP activation increasing with age as well, and trying to connect that with, which is my favorite thing, like the organism level of aging. I did find one really interesting thing, which I thought was super cool. So there is so you mentioned sirtuins earlier on. Sirtuins have a variety of different roles, and one of them is, there's one specific sirtuin, I think it's sirtuin 1, and that's involved in the circadian rhythm.
Yes, right? I saw that.
Yeah. So this SIRT1 is a histone deacetylase, which counteracts a histone acetylase called clock, and it's called clock because it regulates it. It acts in a circadian way and upregulates a whole bunch of genes, and then sirtuin counteracts the effects of clock. Sirtuin 1 counteracts the effect of clock, and so you have this net result of a circadian wave pattern. When you decrease NAD in the cell, SIRT1, because it's dependent on NAD plus, so you decrease that NAD plus NADH ratio, SIRT1 activity goes down, and you get a blunting of the circadian rhythm.
Yeah.
Which is what you see when people age. They get deranged sleep cycles. People, as they age, their sleep cycles shorten. Classic phenomenon. And part of that has to do with the effect of this particular effect, NAD decreasing, so 2-1 decreasing, decreased intracellular cycles of specific genes upregulating and downregulating when they should. And then it happens in the suprachiasmatic nucleus in the hypothalamus, right?
Yeah, which is the sort of main control center, right?
Main control center. But what's crazy is if you inhibit it in the suprachiasmatic nucleus, then it affects the circadian rhythm peripherally as well. So you can, so there's this organismal control of circadian rhythm, which we know because, things like melatonin peak, and you get the circadian controlled paracrine and endocrine hormones that chuff around the body. But this, if you blunt or like mimic this aging related decrease in a specific area, you can affect peripheral tissues and mimic this sort of aging effect. And that to me is crazy. Yeah. And shows, and in some way links this intracellular NAD derangement to an organismal derangement.
Yeah. So going from cell to cell interactions to group of cells interactions to the whole organism itself being interacted. Yeah. I love this stuff, right?
Oh,
this is the stuff I nerd out on hardcore, because you can't just be the cellular guy. You can't just be the organism doctor. You got to be across all of this.
And it's hard. It's super hard.
Very hard.
My other rabbit hole was looking at microRNAs. And microRNAs are a super recent phenomenon. Like, I mean, we've known about RNA for a long time as being a messenger from DNA to proteins.
Yeah.
But microRNAs were really discovered in like 1993, which I guess is a while ago now, but still, I mean, that's less than 20 years.
Yeah. Well, 27. But...
No, 93. Oh, yeah. Anyway, quick maths. Look, arithmetic has never been a strong point.
Oh, good.
Less than 30 years, I should say.
Less than 30,
yeah. Still not that long.
Not at all. Especially in terms of, what we've learnt about cells and how quickly all this has come. 27 is not that long at all.
No. But we know that microRNAs play really a critical role in a lot of cellular regulation. What's super interesting about microRNAs, though, is you can do knockout, like gene deletions of these microRNAs, and it doesn't have a huge effect on the phenotype of an organism, which is actually pretty interesting for a lot of microRNAs. So although they're playing like a super important role, it's almost like they're not critical. They're this redundant role. They're like this fine tuning of certain things, which...
Yeah, the little 1%ers.
Yeah, I mean, yeah. But it's weird. I don't know. It's weird to me that you can do that. Having said that, there's one particular microRNA pathway that's super important in NAD consumption. So we're talking about NAD plus decreasing with age. Well, there's one pathway, one microRNA 34A, which is implicated time and time again in a whole bunch of different things. But in the world of NAD, it blocks one of the recycling enzymes in the salvage pathway, things like NAPT, NADPT. Yeah. It blocks that enzyme. And as a result, you get decreased NAD as time goes on. I can hear a little dog in the background. Doggo.
I can hear that. Yeah, sorry, that's the neighbor's dog.
No, it's awesome. It's beautiful. And so you have decreased NAD with time with microRNA 34A increasing as we age. MicroRNA, this microRNA is innate in the cell. There's like a little pool of it sitting around, and it responds to stimuli, so environmental stimuli like DNA damage. So it's intrinsic. It's upregulated by P53, which is hugely important.
Yes. Yep.
Cell cycle inhibitor of that sort of pathway. So it's similar to PARPs in the sense that you have like DNA damage, threats to of carcinogenesis. MicroRNA 34 lights up and starts tumor suppressing in that sort of scenario. But unfortunately, over time, this tumor suppressing effect decreases NAD plus and is implicated in longevity. In knockouts of microRNA 34, when you inhibit it in older mice, you restore the NAD plus ratio. So it's clearly got a big effect.
Yeah, so we've got all these sort of peripheral answers as to why NAD plus levels seem to drop off with age. All adding to the idea that if we want to limit aging, halt aging, reverse aging, we need to do something about NAD plus levels. We need to keep them as high as possible, or augment them in as many ways as we can, which is no small feat, right? But as we keep pointing out, it's NAD plus is involved in so many different processes in the body. And like most things in the body, there are negative feedback loops. So that when you've completed a job, the end product tells the body to slow down on doing that process again, because we've got what we need. Hugely important. One of the really elegant things that the body does. So who knows, when we try to raise these NAD plus levels, we could just be hitting a brick wall in these negative feedback loops that tell us, oh, it's fine, we've already got as much NAD plus as we need. It makes it a very convoluted and difficult thing to try to impact. But nonetheless, I mean, that's the job, right? No one's discouraged by this. In fact, it's the opposite. It's quite exciting. But leads us into how do we raise NAD plus levels?
A lot of people are trying oral supplementation. A lot of supplement companies out there offering it, various forms, things like True Niagen and the like.
Research is quite lacking in human trials. But it's all sort of getting underway as we speak. There are I've seen a few abstracts that are outlining what they're beginning to do or trying to do in human studies. I think it's safe to say that the main contenders tend to be NMN, or nicotinic mononucleotide, or nicotinic riboside, NR. They seem to be the main ideas of supplementation. I did a quick little bypass into why don't we just supplement heavily with vitamin B3 or niacin, which is, it's an essential thing that we need in our body, but it gets toxic quite quickly in high levels, basically.
It's a controversial history in cardiovascular disease, I think.
Yes, because it did look like it improved your lipid profile, but then it's sometimes at the expense of other areas of the body. It's a great example of why you don't just start supplementing crazy high doses of something that you think is good. Because, I mean, vitamin B3, it's a vitamin, sounds great. Let's take 100 capsules a day. Not a good idea. The body has a lot of mechanisms in place to utilize the correct level of something. And if you oversupply, it can lead to a lot of damage. And in this case, I think the main sort of scary side effect, it can be acute liver failure when you have too much vitamin B3. The liver, you can broadly think of as something that cleans things up and sort of prepares them for use in the body. And too much vitamin B3 just sort of sends the liver crazy. So we know that we've reached a cap when we're talking about vitamin B3 supplementation, and it's not going to appreciably increase our NAD plus levels. So I think what that did was to shift the thinking of researchers and scientists towards, okay, so vitamin B3 is quite high up before it gets broken down in the body to NAD plus. So let's focus our attention down onto these supplements that are much closer to NAD in the pathway, which leads us to NMN and NR. But my friend, was that a rabbit hole and an ongoing rabbit hole at that? For a long time, they didn't know how NMN would get into the cell. We know that NAD plus is simply too big of a molecule to sort of get inside the cell and do its job. It does exist outside the cell and inside the cell, but it doesn't really look like it crosses the cell barrier easily or at all. But things like NMN and NR do. And it was only, I think might have been 2 years ago, 2018 or so, they found the first transporter for NMN. So we know that there is a little entryway, a window that fits NMN to allow NMN to come inside the house and do its thing. But that might sound like a holy grail to people, but again, the further you go in this area, the more you realize that the NMN coming into the cell then has many intracellular reactions and won't necessarily produce the effects that you think it does. Well, what led me to the most confusing thing is a very recent paper that I read that they did radio or isotope labeling of NMN and NR. And then you can that's a way of sort of characterizing those particular atoms in your supplement and then seeing where they end up. And supplementing NMN certainly did raise NAD levels, but the labeled NMN produced non-labeled NAD, which was really counterintuitive. And I can't really say I fully understand that, nor did the authors. But it leads to many more questions around what the body does with excess levels of the ingredients to make NAD and how they all interact. Super exciting area, inspiring stuff, but we're far away from me buying any NMN, I think, for two reasons. One, the research is sort of yet to show the safety and the required dose that I'd need to take as a human and not a mouse. But also it's expensive stuff. It's very expensive.
It's pretty interesting. I mean, just thinking about it in terms of you have a salvage pathway and then an endogenous production pathway.
Yeah.
And you know that NAD plus is crucial for all this DNA repair and all this kind of stuff. And part of the cellular aging process is, we talk about this. I talked about that clock last time. Like, what is the clock? How does the cell tell how old it is, right? And part of that has to be accumulation of DNA errors and DNA damage. And so I guess thinking about how that links in with NAD plus, it's pretty clear. There's a you have accumulation of DNA errors as well as trying to fix those errors, and NAD plus gets consumed in that process.
Yep.
And so there must be some way, whether it's like through the junk DNA or whatever it is, that the cell can record and keep track of how long this has been going on for. In this differentiated state of a cell, because things change when you go back to like an embryonic cell, where that's not true, where that cell could potentially live forever. You know what I mean?
Yeah.
So when do things switch and it starts recording and keeping track of how old it is and the time? Maybe it doesn't. Maybe it's all.
That's true.
But that's a question. That's an open question, I think. NAD, I think, has to play a big part in that, in this intermediate between DNA damage, keeping track of time, and then also because NAD links in with energy production of the cell, then you start seeing how caloric restriction and messing with the innate energy production of cells and tissues can start affecting NAD levels, because we know fasting can affect NAD levels.
Yeah, that's a great point. We should definitely talk on that. Yeah. Besides supplementation, which I just went straight to, we have very, very good evidence, very strong scientific cases of ways to raise NAD levels through, healthy living, as it were.
Yeah. And so in my mind, like, you have this link between energy production, DNA damage repair, the cellular clock measuring aging, all crazy. Now let me throw something even more interesting in the mix. This micro RNA 34 that I was talking about before, quite important in embryological development of cells. So embryological stem cells, part of how they choose, or like the totipotency is partly defined by micro RNA 34. So if you take an embryonic stem cell or an induced pluripotent stem cell. So you take a differentiated cell and turn it back into a stem cell. If you block microRNA 34, then it increases the ability of that cell to choose differentiation paths. So it increases its potency in terms of what it can differentiate into, which is interesting. So again, the cell's waste not, want not. It has this microRNA pathway that is important in the embryological development of cells. It's important in tumor suppression and clearly important in aging as well.
Yep.
And NAD is linked in there.
NAD is the currency of all these different mechanisms that we're talking about.
Definitely, yeah. And NAD can get phosphorylated into NADP. And this phosphorylated NAD is really important in a lot of like antioxidant reactions. So mitigating reactive oxygen species in the cell.
Yep. Which isn't what it was, isn't as important as it first was thought to be when sort of the antioxidant movement came out. It was heralded as this is the answer to aging, and it certainly plays a part. But I think as time's gone on, it plays such a small part in the grand scheme of things.
Here's what's super interesting about reactive oxygen species is the mitochondria produces a lot of them. And they're actually really important intracellular messengers. So they're not just there causing damage, but the cell's using them to send messages from one part of the cell to the other. And waste not, want not.
It might seem like a bad thing, but we'll use it to our advantage.
Yeah.
Which makes me think of the same example we gave with senescent cells, right? Like when you first describe cellular senescence to someone, it's understandable that okay, let's get rid of every senescent cell in the body and we're good to go. But then things like wound healing and embryological development requires senescent cells that you need this inflammatory signal to go out to sort of tell the body where to look. Otherwise, you've got a floating mass of trillions of cells and the body's saying, I don't know where you want me to go clean stuff up.
Do you know what else is cool about microRNA 34?
What's that?
It's important in regulating senescence and the senescence phenotype. As well as telomeres.
As in it's pro-cellular senescence?
Yes. So increased levels of microRNA 34 are found in senescent cells. They've shown that if you inhibit microRNA 34, that you decrease the action of telomerase and telomere repair.
So telomerase keeps telomere lengths nice and long, but if you inhibit that with increased levels of microRNA, okay.
Yeah. Look, I'm not saying that microRNA is like the.
Are you sure?
Like,
you seem to.
Look, I'm into the microRNA, but like I don't know how important or how intrinsic it is. It seems like knocking it out changes some things. It improves things, but maybe at a cost. I don't know.
Yeah. That's the thing, right? Yeah. At what cost? Because it is so important in tumor suppression, as you mentioned, in embryological development. Sort of things you don't want to go messing around with too much, but what's good to know is, as you pointed out before, that this is another huge chunk in the puzzle of why fasting is good for you. I like the idea of describing the way the cell senses the environment. So as an organism, we use sight, hearing, touch, smell to sort of figure out where we are. And it's commonly mistaken we only have 5 senses. The body has a million different ways of sensing the environment. But to zoom down into a cellular level, the cell, obviously doesn't have an ear or eye or nose, but it seems to, among, untold thousands of things, I'm sure. But what is useful to think about is AMP levels, or the ratio that we've talked about before, even AMPK. So the cell can see how much energy is around and react accordingly. It can also see how many amino acids are around and react accordingly. And I think it seems to be able to sense levels of NAD as well. It seems to be another sense that the cell reacts to.
Yeah.
And so when we calorie restrict, or we sort of exploit that energy pathway where we're telling the cell there's not much energy around, now's not a good time to be going off doing crazy things and multiplying to, your heart's content. Let's just focus on cleaning ourselves up and being a good cell that does its job. And we want to boost NAD levels as well, and that seems to be matched with exercise, so that especially that high interval intense training, that seems to boost NAD levels as well. So fasting and exercise, lo and behold, still stands as the pillar of anti-aging. And trying to inhibit mTOR as much as possible. mTOR is the way that we would sense amino acids, I think is fair to say. And trying to exploit that pathway by coming from a man who's eaten meat his entire life, and as a young adult and teenager probably having red meat nearly every day, I will eat my own lifestyle advice from younger years and say we should be eating a fair amount of a much decreased amount of meat, because we don't want to be activating that mTOR pathway.
It's pretty interesting. I mean, that question of what is best to eat is one hell of a quagmire.
Yes. Yes.
And I don't know that we can necessarily say that eating, I mean, it's one of those things. If you put like a nasogastric into your stomach and just pumped you with nutrients all day, that would be terrible. And in fact, from clinical observation, with people on TPN who have like long acting TPN, they always become insulin resistant. And they tend to get this requirement for insulin even if they're not diabetic, because they're having this constant nutrient exposure, which they need because they're unwell, but and they need to get nutrients. But it does have some negative aspects to it. And so there's that aspect to it. But if let's just say you ate one big bolus of meat every now and again, that's probably not terrible.
Yeah, I agree. That's why by no means am I becoming a vegetarian, despite the fact that my wife is vegetarian and my wife's family are 90% vegetarians. My diet has improved vastly since meeting my wife. She's the main cook of the house, so I eat vegetarian meals a lot more, but I still eat meat. Probably I've cut down from nearly every day, which is certainly not a good thing, to maybe I eat salmon probably twice a week, and maybe one serving of red meat a week as well, which I think is achievable in terms of lifestyle arrangements and eating out, although under coronavirus restrictions I haven't been eating out that much at all. But I think it's certainly a healthy sort of advice that I would even say to particular patients once I knew their personal history, etc., that it's probably a good idea to limit the amount of meat you eat to a couple of times a week, and certainly not every day.
I would say I don't know.
Oh, that's a very safe answer. Yeah.
No, but true. I mean, that's sort of a received wisdom from a lot of epidemiological research that's come out being like, oh, red meat is bad and that kind of thing. But I struggle to tally that with reality. And the reason being is I don't think, I mean, I'd have to go, I've gone through periods where I've delved deep into the literature, but it's been a long time since I have, so I can't speak from any level of confidence. But from what I remember of the epidemiological evidence, it's really hard to control. It's always food frequency questionnaires, asking people to remember. I mean, I couldn't tell you what I ate last week.
Yeah, exactly.
And so it's, and I'm not saying it's bad research, but it's just hard to make robust statistical conclusions. And a lot of people in research honestly don't know what statistical tests, the assumptions behind statistical tests they're using, but have access to really powerful software that has these statistical tests.
Yep.
And so
I see what you're saying.
You get a lot of positive p-values, but without necessarily the heuristic or the important theoretical foundation behind it. And for me, I struggle to tally with this idea of something that human beings have eaten since the dawn of time being like bad for you.
I'm certainly not saying it's bad. I love it and eat it regularly. But I think the quantity question, just like in anything when you're talking about diet, it's frequency, it's quantity, and it's quality. It's all the things that, as you've perfectly pointed out, is super hard to control for in a study. If you're saying this person's vegetarian but they're eating Doritos and but hot chips every day, that's a vegetarian diet, right? But and you could say, oh, I eat meat, but you're eating McDonald's burgers is your main source of meat. I think what's become popular, especially through the Joe Rogan podcast, is the idea of the meat you should eat should be as healthy as possible. And what I mean by that is like
is elk meat.
just elk meat, nothing else. But I do subscribe to that idea that the meat you should eat should be just like the quality of fruit and vegetables you're looking for. The fresher the better, and the less sort of processed the better. But that's hard to do. I live in region of Victoria, but I don't hunt. I've only hunted once or twice in my life before and really liked it, but certainly that doesn't fit into my regular lifestyle. Although there are a few farmers that I know and my father-in-law knows that I think I'm going to speak to and try and get a set of meat. There is actually a guy in the hospital who I met who does his own hunting, and he gave me a huge amount of red meat that he'd hunted himself. And super nice guy. I'll have to introduce you to him. Actually, it was awesome. It was so good. He and I hit it off. He's he's a gym junkie. He's really into his fitness, everything else about it. And we sort of got chatting on the ward, and we were talking about this topic of where you get your meat from and protein shakes, etc. And he said, he gave me a huge amount, and he wouldn't accept any money for it as well. I had to pay him sort of like indirectly. I left him an envelope with the nurses that he had to like just take and couldn't refuse because I wasn't there, sort of thing. Very nice guy. Very nice guy.
Yeah. To be like, to balance out what we're saying here with the ethics of it, maybe like my personal take is that if you go to the supermarket and buy meat, it's probably not the best ethical decision. It's supporting like an industry that's not great for animals. And I would say if you're going to eat meat, like the best meat is hunted. I think from an ethical perspective, it connects you to nature. I think it's like a better strategy, but ultimately I think the claim that, not eating meat is optimal for health is wrong, in my opinion.
I would agree with that statement. Yep. I don't think
and so I think because I'm a person who likes doing things that are healthy, I will go to the store and buy meat, and I will eat meat for that reason. But I will suffix that by saying I'll acknowledge the ethical quandary with that.
And even applying heuristics to that concept as well, because I completely agree with what you just said, is it's difficult to hunt, right? You don't always end in a successful hunt. And I think the heuristic there is that meat is good for you, but probably in line with how often you would be successful with your hunting and the energy you put in to get the energy out. It's probably not something your body's used to having in super large quantities, easily accessible all the time, which would lead to, this is a bit of a leap. There's a lot of intermediate steps, but it would lead to chronic mTOR activation, right? Which isn't necessarily a good thing for aging. It's a bit of a leap to say that, but
Yeah.
That's the way I think about it, resulting in the idea of I'll cut my meat consumption down to a couple of times a week, but certainly not every meal, which is what it used to be when I was living a bachelor life. It was sort of, I have my meat, which was any sort of range of meat, and then throw some veggies on the side. That was nearly every meal, including breakfast. So I'm not sure that was the healthiest approach, but
It's pretty interesting. I mean, I wonder what our human ancestors really did. I mean, clearly there was some gathering, and clearly there was some hunting. The proportions of that, hard to say. I know there's some evidence, and look, I don't know how good the evidence is, but that we're looking at hunter-gatherer skeletons versus, say, ancient Egyptian skeletons or agrarian skeletons, the hunter-gatherers are much healthier than the agrarian who appear to have a lot of the diseases that we have as a result of probably eating excess grains and that sort of stuff. Because once you start farming, you have this steady supply of food, which is awesome. But the type of food it is probably not what we were evolved to eat.
I would agree. This area is so fraught with tribalism, don't you think?
It's tough, man. It's tough. Yeah, people have really strong opinions one way or the other.
Very strong. And I don't, I kind of don't like the term vegetarian or veganism or meat eater, because it's just too simplified. It's like saying, NAD is good, so let's supplement. It's like the question is so much more complicated than that. It's rarely that simple, and people seem to think in very simplistic terms.
The reason why I think a lot of the studies show meat being bad is because people are eating meat with, a Coke, and they have like a huge. You're eating meat with a big insulin hit at the same time, and I think that's probably just the worst of both worlds. I think meat in isolation is probably good. I think some carbohydrates in isolation is probably good. But I think there's something about the combination consistently 3 times a day for a long time that's clearly terrible. So, I don't know. It's tough. Linking it back to NAD, I will say there's some interesting evidence that a ketogenic diet and ketones in general improves NAD, the redox state of cells. How that is, I don't know. I know, for example, in exercise, especially, if you exercise for an hour, your beta hydroxybutyrate will go up. You'll make some ketones. And that if you fast for a period of time, you'll make some ketones. And this beta hydroxybutyrate in particular is one of the ketones that you make, seems to trigger certain seems to be a messenger of some kind and trigger certain responses in cells that is quite good for you in the long run. So clearly a low carbohydrate approach, in my opinion, is much more likely to allow you to have intermittent increases in beta hydroxybutyrate and therefore likely to be better in the long run, I think.
And boost NAD levels. So I think the only things we can say for sure is that fasting, exercise will boost NAD, and we know that NAD drops off when we age, and that maintaining it seems to stave off a lot of the phenotypes of aging. And that supplementation seems to have merit, but in what form and how available, how cost effective, how dose dependent is a huge question mark. But I think it's I don't want to hype it up too much, but I think this is going to be a revolutionary stage in the aging world. If you can identify supplements that produce the same effect as exercise and calorie restriction or intermittent fasting without necessarily having to do them, I mean, that targets a whole area of the population that you and I don't fall into. Like I like fasting and I like exercise. Even if I could have the effects through a pill and not have to do them, I would still do them.
Definitely.
Whether or not it's additive, and if you were to exercise and fast and take a supplement, you would get even better results, then sure, I'll do it. But Similar to metformin, where it's still a bit of a question mark whether or not exercise and metformin, they seem to definitely, that's a known factor that they produce the same results in terms of anti-aging effects or longevity effects. But whether or not, if you do one, you sort of ruin the path of the other. And in that regard, I'll choose exercise every day of the week because I'm addicted to it. So whether or not supplementation is simply doing something that we can already do for ourselves, it's still going to be a revolutionary step in longevity, because there's such a huge amount of our population doesn't exercise enough and doesn't eat or doesn't fast to any great extent. Sometimes it's completely thrown people out of the blue. Like, you want me to skip meals? That just sounds absolutely crazy. Like, and there's certainly a tiny subset of the population that you don't want to tell to skip meals. People who have eating disorders or issues, they certainly need no encouragement to eat less. But broadly speaking, we definitely need to be eating less and exercising more. There was a thought I had there. I can't remember what I was leading towards. It'll come back to me.
Nah, it's all good. But good advice. Good advice nonetheless.
Yeah, good advice nonetheless.
Yeah. I bought some True Niagen a couple of years ago now, I think. I took a little bit and then just stopped because I didn't like the evidence for it. I didn't think it was strong enough. Having said that, to be honest, like, I take alpha ketoglutarate, and the evidence is probably similar. Like, there's no strong human trials to say.
Yeah, right.
It's just that we know that the safety is good. Whereas I guess I'm less convinced about the safety of nicotinamide riboside.
Yeah, I agree. I had that same realization in the last few days in the research I was doing for this podcast. Well, I take alpha ketoglutarate, and it seems to the level of evidence is in a similar category. But as you just alluded to there, the safety profile is such a known quantity. And you and I are at an age where the urgency is beginning to ramp up, but is not there yet.
Not there yet. I think, me personally, I think, like, I almost feel like I haven't hit prime yet. I mean, I'm 31, but I still feel like, 40. 40 is like,
might be the number.
It's going to be peak. Yeah.
I'm 30, and certainly if I use ambiguous measurements like performance in the gym or performance in martial arts, I think I'm around my peak around now. Certainly I'm lifting the heaviest weights I've ever lifted before and feel as strong as I've ever felt before. Thanks to coronavirus, hunkering down and focusing a lot more on the gym. Because I've still kept my karate up, don't get me wrong, but it's hard to measure your performance when you're training in isolation. I've been teaching my father-in-law martial arts, and he's coming along in a huge way. I'm super proud of him. But I'm yet to sort of, get back with my regular karate crew and go hell for leather against each other and see how quick my reflexes are or how strong my conditioning is. But certainly gym-wise, I'm peaking or still improving. So I think I agree. 40 seems like a reasonable number to start.
Yeah, I think most people say, like,
the frequency of our podcasts.
I mean, 40, I think people say, is when things start to decline. We start to feel the decline more than anything else. Maybe if you're like a really terrible 30, maybe you sort of feel like 30 is it. But I certainly don't feel like this is the decline yet. It's interesting. Like, I'm sort of looking forward to observing my own aging and seeing what form it takes.
Yes, I wish I was born a twin.
Oh, mate.
That reason.
Yeah. Wim Hof, the breathing dude?
Ah, yes, yeah.
What's amazing is that he actually has a twin. So it's like this real natural experiment between him and his twin. It's kind of a funny phenomenon.
Is the twin into breathing like he is, or
no? So it's like this perfect control,
awesome.
Genetic control of, like, the Wim Hof method. I actually don't know what the results are from between them. I know they both had the same level of brown fat, which is interesting. So Wim Hof does the cold exposure, and everything, and he's breathing, and yet they had the same brown fat. So it's sort of like, well, there must be, that's genetics, more so than anything else. Unless the twin of Wim Hof is also just living in a cold environment.
Yeah, the broader environment having the effect more than anything else. Yeah. Well, I think we've characterized well that NAD is super important and definitely an area that needs attention, but the usability beyond fasting and exercise seems to be a big question mark still.
Yeah.
But I am very confident to say that this is the next revolutionary step, where if we can find a safe supplement that will boost these levels, we're going to target a huge area of the population that, for various reasons, both intrinsic and extrinsic reasons, can't fast or can't exercise the way they want to or should be. Then watch this space. This is going to be a huge area. I
mean, there is some good evidence in animal studies. So, like, for example, in
fantastic
mice,
evidence. Yep.
NR has been shown to protect against noise-induced hearing loss, which is a pretty amazing phenomenon, by activating SIRT3. To me personally, I find like this idea that you can reverse noise-induced hearing loss to be like such an interesting idea, because I remember being taught at medical school that noise-induced hearing loss is irreversible. That in fact, once these cells in the ear die, the hair cells and stuff, they can't be replaced. But it certainly seems like they can.
And even NMN supplementation, which they've done in mice. I mean, there's that great example that David Sinclair, the Harvard professor of genetics, always discusses, where the mice that he treated with NMN broke the treadmill because they were running 3 kilometers, and the programmed sort of governing body for the treadmill didn't think a mice could ever run 3 kilometers, so it sort of broke down and stopped. Pretty powerful evidence there in animal models. And even I think he's quick to point out that this is mostly anecdotal, although that was quite a while ago in his book, so perhaps there's papers. I haven't looked into this, so forgive me if someone in the audience is screaming at me saying there's evidence contrary or even supporting what I'm about to say, but there's anecdotal evidence that people taking NMN supplementation, humans who were postmenopausal, started to enter into perimenopausal and even back to regular menstrual cycles, which really flows in the face of the concept that you and I probably were both taught, that you have a finite number of eggs as a female that transition through to being, essentially 0 eggs available in the ovary. But whether or not they're sort of pluripotent stem cells there, or some mechanism as to which to recover the ability to produce more eggs, and whether that's an NAD plus dependent pathway. Again, I'm not putting words in David Sinclair's mouth. He's certainly not saying that it does that, but it just there seemed to be this anecdotal trend amongst people who were taking it, and I should do further research before I say any more, but it's an interesting concept.
Yeah, that's a cool concept. Very cool concept.
Yeah.
Because oftentimes you find longevity promoting things reduces fertility, but it'd be interesting if something like this actually improved it.
Yeah, because that seems to match that idea that you don't want to be reproducing or producing offspring, right? When you're talking about longevity, you more want to cause the cell to hunker down and focus just on itself.
Exactly.
But maybe the ovary has an inverse relationship to these factors,
or it's just a simple fact of it's turning the clock back in ovarian tissue. And uterine tissue.
The organism level of the ovary being reduced.
Yeah. Super interesting. I'd love to hear or see if there's any research on the effect on sleep. Because if you're restoring your circadian patterns, that to me is like then that to me would be like a powerful clue that you're affecting organismal aging.
Definitely. And they
improve.
Sorry, thank you.
I was just going to say, if you can improve sleep and circadian patterns, that's what I was Yeah. Same.
Because like we've pointed out, things like insulin sensitivity that seems to go off with aging. I mean, I forget the exact study and the exact statistics, but something like, after 5 or 6 night shifts in a row, you can be classed as pre-diabetic by standard protocols. And I've just completed 7 nights in a row working 11-hour night shifts. It's horrible news to sort of say to myself.
And it's really tough because our Resi's room has like a huge tub of Nutella, all this fruit and bread.
I have to say my fasting improves with night shift, paradoxically. When I was working at the private hospital earlier in the year and even the shifts I'm doing now, I tend to fast 19, 20 hours when I work night shift.
Nice.
My last meal is whilst I'm still at home. And because the night shift is so consuming and sort of dreary natured, I find it easy just to, I'm not even going to worry about food. I've got so much to do or so much to think about. And then all of a sudden you're back home and I can go to sleep on the empty stomach. I know that's a good thing for sleep. That doesn't bother me at all. And then I wake up and lo and behold, it's been 19, 20 hours. And I have a traditional breakfast. I have something as soon as I wake up, which I normally don't do at all. Sleep is a very interesting topic. And it would be crazy to think that it doesn't relate to aging. I think it's very, very intrinsically linked.
Yeah. Anecdotally, when I've been on a ketogenic diet and I've had like good and high ketones, I found night shift easier. But also I found like what's weird, and it sort of tallies against what I was saying about the circadian thing. But I often find that I need less sleep. Like I find I wake up earlier. And so there's a weird change in my circadian rhythm being on a ketogenic diet and specifically being in ketosis, which is weird, which I have to think about a bit more.
Again, I think it's a traditionally very difficult area to study sleep. It's hard to run a sleep lab where you can really control for a lot of things, and self-reporting is just absolutely horrible. I mean, people often say I didn't get any sleep last night, but if you really drill down to it, they still got 5-6 hours, which is not enough by any means, but it's a far cry from zero sleep. So yeah, traditionally a hard area to study, especially with large sample sizes, but the works that's coming out of sleep study is incredible stuff. Matthew Walker, he's a professor in America who I've read his book Why We Sleep. It's probably the top 5 books I've ever read. Right up there with Lifespan by David Sinclair.
Yeah, I've just been holding off on reading that book because I just don't want to get depressed about how I sleep.
Yes. The tips he talks about in the book I've employed, and it definitely improved my sleep.
What kind of tips?
Things like lowering your body temperature, which is paradoxical, right? If you ask anyone, what are the conditions where you need to sleep well? People think, I'd have a huge meal and I'd be in this nice cozy room, and then that'd drift me off to sleep. But really, things that improve your sleep is going to bed on an empty stomach, or at least waiting 3 or 4 hours after a meal, and also lowering your body temperature. Which he talks about with the sauna example, because people say, I'm in the sauna, I get out of the sauna and I can fall straight asleep. That's arguably because you're increasing the blood flow to the peripheries of your body, and then as you come out, you can radiate off so much of that heat that you can lower your body temperature and get to that nice sleep state.
Interesting.
But also just like probably the largest effect that it had on me was the paradigm shift towards not feeling guilty about wanting and needing sleep. Society tends to reward someone who is so busy that they only sleep 4 hours and they still manage to get stuff done. Whereas similar to, someone who's too busy to exercise, that's not a good thing. That's certainly not a sustainable thing. So the idea that if I'm tired at 8:30 at night, I'll go to bed and won't worry about it at all. I mean, it's changed since I've had a baby girl, but a little bit all over this. But my wife would be rolling her eyes hearing that, because she certainly carries the heavier load overnight with breastfeeding, etc.
Yeah. I think I want to temper that with perhaps this idea of the big drivers in human history, the people who push human civilization forward. And there's a certain element of self-sacrifice to that role, to those people who do that, that it's for the greater good. And so while I agree that like we shouldn't necessarily glorify 4 hours of sleep a night and that kind of stuff, in a sense, it's almost like a necessary story to allow those people who are really going to push our civilization forward to destroy themselves doing it, because that's almost what it takes. I guess that
I see that argument.
The reasonable question would be like, should we be fostering a civilization where that's not what it takes, where you can achieve and push humanity forward without that? But it's almost like I don't know. It's almost like you need it to really go to that next level. The CEOs of the greatest companies don't, who are driving progress, aren't necessarily, getting
well rested. I'm not sure I agree, actually. I think who is to say that those CEOs or those companies wouldn't do better if that CEO was well rested, exercising well, eating correctly?
Well, that's another reasonable question. Yeah. I guess the problem is we're hyper competitive, and so the reason why we default to that position is not because it's because it's an effective position, because in those extra 3 hours you get more work done, which outcompetes the person who's not getting those 3 hours and work done.
Whereas I'm a guy who more subscribes to the idea of the quality. So I go to sleep. Yes, you stay up, you're working, but then I wake up well rested, and that the next 2 hours of work that I do equals the 4 hours of work you did in an exhausted state.
Yeah. I guess the other thing too is most people are working in bursts. So it's actually very seldom that you're doing 4 hours of night every night forever. It's more the case that there's a deadline coming up and you need to do it for this period
some
of
extrinsic
time.
factor that pushes. I agree to that. I think I had to adopt that mentality when I was competing in karate to a really high level. I still compete every now and then in karate, but 2012, for example, I fought in a world tournament in Kyokushin karate, and that was the busiest year I've ever done in karate. I competed in the state titles, won those, competed in the national titles, won those, competed in New Zealand titles, won those, competed in Japan, and certainly didn't win. It's a world tournament, but I was ranked in the final 32 in the world. So very proud of that aspect. But all the training I did leading up to that required stupid amounts of karate training. But I had to temper myself, because overtraining is a real thing. And I'd stop training and think, these world champions that I'm going to be fighting are probably training right now, but it's about the quality that you put in. And resting is part of it. That's the bias that I approach that topic with, at least.
I guess that's a question that if you find yourself in that position where you're having to sleep 4 hours every night, maybe taking a step back and assessing what how you're approaching the problem is a reasonable thing to do. Could you be structuring things differently? If the answer is no after a careful analysis, then continue, by all means, continue. But if the answer is I probably could, I'm doing this because I don't know, I feel like I need to, then rethink what you're doing.
Work smarter, not harder.
Or work smarter and harder. I don't know.
Beautiful. All right, shall we wrap it up there?
Let's do it. Might as well.
And so stay tuned for the next episode that hopefully will be coming from our night shift, working together in person.
Talk about circadian stuff. We should like delve into circadian rhythms and.
Yeah, I'd be keen. Yep, that sounds good
Yeah.
to me. Yeah.
Cool.
Awesome. All right. See you then, mate.
See you, dude. Yep. Hey guys.
This is our end of podcast medical disclaimer.
Yep. Although we are medical professionals, this is not medical advice, and this does not create a doctor-patient relationship.
It's not prescriptive and not intended to be so. We always recommend seeing your primary physician in the first instance. This is mainly for education and entertainment purposes.
Absolutely.